This material is made available to you by or on behalf of the University of Melbourne under Section 113P of the Copyright Act 1968. It may be subject to copyright. For more information, visit the University Copyright website.
All right, good morning, everyone. First of all, I see some familiar faces, which is nice, probably from systems modeling. Who doesn't know me? Okay. So my name is Rina, and I'll be lecturing all of that. I'm working here. Oh, that's yours. I'm working just as a lecturer. I'm not doing research. I get asked a lot, what's my research? I do supervise some capstone projects, but my main focus is teaching and improving the teaching of myself. No. Okay, so today we have 3 lectures, right? Because I recently became a mom, so I wanted to lump everything to one day and stay at home as much as I can to care for my daughter. Come in, take the one. So what we are going to do today is 3 things. The first one is me trying to not really motivate you, that will not work, but explain roughly about the subject, what we are going to do this semester. Then I'm going to go through the administrative stuff that you have on these subject information pages. And then finally, I'm going to teach something so trivial but very important, which is the right-hand rule convention that we are going to use here. And the reason I'm doing it first lecture is that in the past when I didn't, there were some misconceptions and people didn't know exactly how to use the right-hand rule correctly. So I want to have everyone on the same page for that, okay? By the way, this keyboard was here prior. I didn't plan to play for you. Okay, so first thing, this slide is for where this subject dynamics is in your curriculum. All right, do some of you do control this semester? Yeah, so the relationship between dynamics and control, do you know? Why would you need dynamics for control? My first question. Sorry? Say again? Modeling, exactly. So in this subject, we are doing mechanical modeling of systems. And in control, if you have some ability to actuate a system and influence the forces and torques applied on it, you can control it to do what you want, okay, if you study well. What's the relationship between the previous knowledge of statics and dynamics? Trivial. In statics, you care mostly about what? About what? One moment of time in which nothing moves, right? So you mostly care about equilibria and static, stationary systems, boring systems. But you do learn to analyze the forces and moments of the system, and that's important. We will use that. If in previous subjects like engineering, mechanics, or whatever, you learn the component of dynamics, other than the forces and moments summation that you learned how to do, like the sigma F, sigma M, things like that, other than that, forget everything, okay? Because I want to teach you all the dynamics part from scratch, all right? And then the future subjects, if you want to take them, robotics, again, you need the modeling. You need to understand how to mathematically represent the system that you're working with, say, the robot, and then you will be able to control it, okay? Advanced control, same as like control. You need the modeling of the system. You need your, essentially, equations of motion for the system. And in advanced dynamics and dynamics are two subjects that have the same goal, producing equations of motion for a mechanical system. But in dynamics this semester, we are doing it from a physical point of view. We are doing what's called Newtonian mechanics. So we will be working primarily with vectors, 3x1 vectors. And in advanced dynamics, we are taking the analytical mechanics approach, which is primarily mathematical, okay? So less vectors, more scalars like energy and work and things like that. All right? Now, this is my first student. This is my daughter. Yesterday, she's 2.5 months, and she already fell asleep at this slide. Yeah. If I can make you fall asleep, it means I'm good at that. And this is important in this stage of my life. So I've been talking about what we are using dynamics for. I'll briefly summarize it. So I gave here 4 uses that you will be able to apply in general. This is your sort of overall learning outcomes from this subject. So finishing this subject, you should be able to do these things. Predict the motion of a mechanical system. This is the primary thing of this subject. Given some initial state of a system at a particular time, and by state I mean, say, the positions and velocities of the different parts of the system, you should be able to predict how this system will evolve in time for all future times. Okay, this is the goal for this subject. And of course, assuming you know exactly what forces and torques are applied on that system. Okay, so this is one use, knowing the forces to predict the motion. The second use is knowing the motion to be able to figure out what forces and torques created that motion or made that motion happen. Okay, can you think of some application for this second point? Well, I was thinking about this one, and I'm not a biomechanics person, but say if you are filming someone running, and you can analyze their motion and predict, using the analysis of the forces and torques inside their joints, how long until their bones are cracked, let's say. So looking at the motion, trying to figure out what are the forces and torques on the system. Control, it's pretty obvious in robotics. In control, you will take the equations of motion and you will apply whatever control law you can from whatever you study in control. Okay. And then the final one is to do with collisions. So if you have two bodies colliding, if you know something about these bodies, the materials, and so on, you can also predict what will happen after the collision. And this is a topic that we will do at the end of the semester. It's a bit different from the first one because it deals with an impulsive force acting between the colliding bodies, and it is different from what you learned so far, because we are not just going to talk about particles colliding, but actually potentially some systems with different links, and one link here collides with another link here. How will it affect on the rest of the links? Things like that. Okay. Okay. Now, starting from scratch, everyone should be familiar with this one. If no, you just landed in the wrong department, I guess. What is this? Newton's second law. Good. So in statics, you had this A, 0, and you were primarily equating everything to 0. Okay. So this subject, we are mostly going to look at the right-hand side. Okay. Not only, of course, we are going to do the equation. Now, this is for a particle. We are going to talk about rigid bodies, not fluid dynamics here. For rigid bodies, if you have a whole volume of a body, how can you use Newton's law to predict the motion? So we'll have similar equations. Both of these equations, we will work with them. We will call them Newton-Euler equations. I'll get to them kind of midway of the subject. These are not the equations of motion. So from constructing these equations, we will get the equations of motion, okay, later, after doing some mathematics. So what are these equations? The first one, if you just look at, say, this. What you see here, this P dot. P stands for linear momentum. Dot stands for derivative with respect to time. All right? So it is pretty much the same as this one. This is also the time derivative of the linear momentum, assuming that mass is constant. Okay? If you can't follow me at this stage, that's fine. Okay? We will do it step by step, bit by bit later. So maybe just try to remember the right-hand side of these equations for the next slides. This sum of moments, this letter G stands for the center of mass of the rigid body, because we will be writing these equations for every rigid body in the system. And for a rigid body, how to define its linear momentum, because it's not a particle. Particle, you just need the position of that particle. For a rigid body, you have many points on that body. So we will see that the linear momentum is the mass times the absolute velocity of the center of mass of that rigid body. Okay? Now, what you see here, r dot, r would stand for position vector, r dot would stand for velocity, r double dot would stand for acceleration. Okay, we'll get there. Okay, now here we have this omega. It is standing for angular acceleration, sorry, angular velocity, and I about g, about the center of mass, is the moment of inertia, or tensor of inertia, I should say, of that rigid body, okay? Calculated about the center of mass. So I just thrown a lot of new terms on you. Don't worry, we'll get there bit by bit. Okay, so this Newton's second law is the theory behind everything we are going to derive later on. So we are going to obtain these equations from this equation. Okay, now this equation is a good approximation for our everyday physics, right? We are not dealing with relativity stuff here. So normal, everyday objects, not too small, not too fast traveling. And of course, there's no proof for that one. This is a law of nature that Newton just modeled for us. All right, so everything that we are doing here assumes this is the way our world functions. Okay, and that's very philosophical if you think about it. Why necessarily so? I don't know. Okay, so just remember the left and the right parts, okay, for the next slide. Here, a bit old-fashioned to have memes, but probably the last one you're going to see in my lectures. Third law of emotion. After the birth of a child, this is so true, okay? All right, let's keep going. So here, this is what I told you. Remember the right and left sides. By the way, I'm being filmed here. Last year, I tried to get filmed in a studio, and I was trying to do the right-hand rule, and having the screen beside me like a weatherman. They swapped my right and left, and I had to bring my wedding ring to the other side and do everything with my left hand. It was too cumbersome for me, so I brought you in. Thank you. Okay, so we are going to study this subject in a kind of pyramid way, bit by bit. And the first bit is kinematics. And the kinematics knowledge is the right-hand side of these equations, which says we want to characterize the motion of the system just to be able to say where every point is in time. In a parametric way. So characterizing this motion, disregarding the forces and torques causing that motion is kinematics. And this is what we are going to build in a very fundamental, bit-by-bit way for, I would say, at least a third of the semester. Okay, so at least a third of the semester, we forget about forces almost altogether. Okay. And what we are going to cover is, first of all, the r, the position vector. And even before that, because we are dealing with vectors, we need to represent these vectors. We are going to use Cartesian coordinate systems. And not just the stationary coordinate systems, but also rotating coordinate systems. And in order to be able to conveniently transition between one representation and another representation, we are going to talk a lot about rotation matrices today, later today. Okay, so first, coordinate systems and rotation matrices. This is the mathematical framework we are going to use throughout the subject. And unlike other dynamics subjects in different universities, we are going to focus a lot on 3D motion, okay? Whereas other universities, dynamics, at least the basic subjects, they primarily focus on 2D motion, okay? So you are in good hands. And then position vectors like r, okay, without the dot. Then angular velocities like this omega. And then in order to do the dot or the time derivation appropriately, even if a vector is represented in a rotating coordinate system, we will need to learn how to do it correctly, because it's not that straightforward as you would take the derivative of some function f of x. Okay, it's a little bit trickier. We are going to spend 2 lectures on learning how to take a derivative of a vector represented in a moving coordinate system. And we are going to talk about, at the end of this kinematics thing, we are going to talk about different structures of 2 bodies connected together via some joints, and think about the forces that could be applied between these 2 connected bodies, okay? As a preparation for the dynamics part. Now, the dynamics part, actually the inertia tensor here, it's a bit more related to the kinematics, but other than that, we are focusing essentially on not just the left-hand side, but on constructing these equations. So say after you've prepared your right-hand side, constructing these equations, both left and right. Okay, so this is going to be considering the actual forces and torques on the system, and the main thing would be, well, correctly writing the free body diagrams, all right, and then setting up these equations, which I call, well, this is how they are called, Newton-Euler equations. Okay, and from these Newton-Euler equations, we are going to extract the juice, which is the equations of motion, and then, well, after you have the equations of motion, once you solve them, you can kind of go back to your system and find out the values over time of all the forces you are interested in. Okay, sometimes you will do that, sometimes you won't care about these forces. After that, there is a part of animation that we are going to deal with, or first numerical simulation, or solving these equations of motion using MATLAB. And the reason we are doing that is we don't want to end up with a bunch of equations and go away. We want to see how the system is moving, right? Using your equations to verify that your equations make sense, right? Because everyone has some intuition from everyday life, right? If you just look at a ball under gravity, right? If you write the equation of motion for that ball and then you go to your computer and simulate it, and then the ball is doing some spiral skywards, you see that something is wrong with your equations, right? Then you go back and check. But if you don't see something visually, you may have the wrong perception that your equations are fine. So it's important for us to learn and know how to use the equations and solve them and animate our system. And in particular, we are going to do that in the practical. So in the practical, you're going to film a toy gyroscope, and then all the lab work afterwards, you're actually going to simulate and show, kind of proof that the equations of motion are correct by showing the animation of that gyroscope using MATLAB and showing that it's the same thing as what you filmed in your lab. Okay, I'll talk about it a bit later. And then, as I said, the final topic is collisions. Okay, so we'll be talking about colliding bodies. And with these equations, for collisions, we will actually integrate these equations over time so that we can have useful equations for impulsive situations. All right? Okay, so I think I finished what this subject is about. Are there any questions in general? Are you worried about not covering something? We are not doing vibrations, by the way, in this subject. Not covering that one. Okay? Okay, so what I'm going to cover now is the administrative things here. So maybe first open, sorry, I'll just close here. Yeah, so now I'm going to talk about the good and the bad and the ugly. Okay. So first, let's look at the structure. All right. Now, for example, if you look at the way this subject is constructed, we are having a lecture first about some topic, and then you will have a tutorial about that topic the following week, right? I didn't cover any MATLAB stuff yet, but I did want to utilize your first week so that you can get familiarized. I mean, you did have the time slot in your timetable, so I wanted you to get some MATLAB background in this first week, okay? But from now on, first I lecture, and then there will be a tutorial. So today, later, I will cover rotation matrices. Next week tutorial is about rotation matrices. And then the following week, you will have a workshop, or what I called in previous times, study group or group study. In this workshop, which is not formal, you can practice rotation matrices mostly on your own with your friends. Okay, so we are booking a room for you, and you are welcome to go there and practice. And I requested the tutors to attend that, but they will be mainly taking questions, not teaching as in a tutorial, all right? So that you can practice some peer-to-peer interaction, right? And why do I do that and encourage you to attend? About 2 years ago, I attended some seminar from mental health at UNIMELB here, a mental health representative, let's say. And I was quite shocked to see that the leading cause of death is suicide for your age. And I was thinking, okay, how can I do something about it in my ability? And I was thinking that a lot of the depression happens because of isolation. And now with all the online, everything is online, many people just get into their shell and stop interacting and become very lonely. So I did want to give you an opportunity to just see another human being and talk to them the normal, old-fashioned way. All right? Okay. Now these workshops will be advertised as we go. So if you can't make it to one, perhaps the next ones will be different time, different place. Maybe you can make it. Now, assignments will be due Sunday, the end of the week. So let's say the first one will be at the end of week 5. By this time, you would have covered the material long time ago, okay? And if this is due, say, Sunday of week 5, then Sunday of week 6 is when the solutions are posted, okay? Not only the solutions are posted, you will be able to see on that following Sunday your answers. It's all online quizzes, kind of either multiple choice or insert a value type of questions. Okay, so they are not manually marked. I will talk about the assignments a bit later. And here, lab session, just in week 6, whatever you see as prac in your timetable, it is relevant just for week 6, okay? 1 hour only. During that hour, you go and you film your toy gyroscope, all right? This is the only time. And after that, you are working with your group on the report, all right? This is the majority of the work. And the exception, or the change from last year, is just the due date for assignment 2. I shifted it a bit. I shifted it from week 9 to week 8. Why? Because the lab work, or the submission of the lab, is related to everything you're doing in assignment 1 and assignment 2. So I wanted the solution for assignment 2, which will be posted, remember, the following Sunday, to come up before you need to submit your lab report, so that you can check your equations like a week before your due date for the lab. Okay, so this is my change, but there is a flip side for that. When you need to submit your assignment, the material for that is pretty tightly covered in tutorials on that same week. Okay, the lecturers would finish covering it, but yeah, it will be a bit tight for assignment 2, but then useful for the lab report. All right, so I just received feedback again and again to align the assignments a bit better with the lab report. So I'm doing it now. Let's see how it works. And then, well, another comment. The Friday, Good Friday, Best Friday, there would be these changes. So in the front here, you will see these 2 changes for the lecture and for the tutorial for whoever goes to the Friday tutorial. These are the modifications because I don't want to miss that. And I changed a little bit the syllabus, because so far I happen to have Anzac Day and Good Friday always canceling 1 lecture. So I always lectured for 34 lectures in a semester. And this one I decided to return the Good Fridays because everything is on Friday, so we are losing 3 lectures. I said, okay, that's it. And we will have 36 lectures, so I'm slowing down actually a little bit around the middle of semester. Okay. What else? Yes, so assignment 3, end of week 12, and I will soon talk about the assignments a bit more. Right, so I put here a table for you for when the assignments are released, when they are due, and when the solutions should be available, and when it is marked. So when you see here when submitted, I just want to make sure if you come from a different university, when you submit your assignment, you can click OK, and you will see your mark, but you will not be able to review your answers and which ones are correct, which ones are wrong. You will be able to do all that a week later, all right? Okay. Yeah, so for assignments, I want to be very open. I don't change much from previous years. Why? Because these are quite good assignments. They teach you a lot, and it's a huge amount of time to think about good questions that you can solve. The only change I'm doing in collaboration with the tutors is, well, we previously had very long expressions as final answers, very long expressions that you could generate using MATLAB. And you had to, it was a multiple choice, let's say, with every option being huge, okay? So in order to change that, this semester we are substituting values, and just you put your final value as the answer, okay? Now, is it easy to cheat? Yes, very easy. And I will talk about it soon. It's 10% each of these, okay, lab, assignment 1, 2, 3, 10% of the final mark. and then the exam is 60%, and it's a hurdle. It's a hurdle like all the subjects now should be hurdle exam, okay? And this hurdle is to find out who did what in the assignments, roughly. Because it's really easy to get 100 in all of your assignments, but it's a deception, you know. So be very honest with your assignments. For the lab, I will just play that. So this is the filming that the previous group did in the lab itself, and this is their MATLAB animation that they created to check their equations of motion to simulate this gyroscope. All right, so this is it won't work. All right. Okay, I'll upload that as a video later. Sorry about it. Okay, so this is the topic, gyroscope motion, how it processes, and you will think why, and you will need to report about this experiment. As I said, only in week 6 it takes place, the actual going there. You will take a seat, okay? You don't need a computer, so you will just take a seat, and whoever sits next to you, the demonstrator will take your details and give you a sheet to kind of sign how you distribute your work, okay? And we'll make a group out of you. So if it happens that in your session you have your friend you want to be with you, okay, you can be together. But otherwise, random people could join you, just sit next to you, all right? Now, attendance is compulsory, and I will keep reminding you that because you need to actually physically go to that 1-hour session. If you have any problems attending your week 6 practical, let me know as much in advance as you can, all right? So compulsory means if you don't, and there is no good reason for it, you get 0 for the lab component, okay? So it's another kind of attendance hurdle for this subject. Okay, final exam. Whew, I need to rush. Final exam. There is another change from past years. Past years, it used to be open book, so students would print tons of my lectures and tutorials and bring all the books they could. And it was just a distraction, to be honest, because you don't need that, okay? And this year, it's a closed book exam, okay? I will not change anything about my strategy of writing the exam because I never really took into account it was an open book exam other than not repeating past questions, okay? Which I intend to keep doing. The format is, so far, normally I do 3 or 4 open questions. I get that asked because your assignments are about 30 questions, multiple choice, so it's a different format from assignments. You will see different practice exams, so don't worry too much. I don't completely revolutionize my exam writing. So you can only bring a calculator, no formula sheet. I also don't supply a formula sheet. We will just have a handful of formulas in this subject, and I know that you can remember them. Okay. Now, when we are talking about inertia tensors, there are lots of kind of from the shelf inertia tensors ready for you to use. I don't expect you to remember any of them. Okay. I do expect you, say, to remember the formula for how to calculate the inertia tensor for a new body. Okay. Things like that. So just a handful of formulas, and you won't struggle to remember them. Okay, hurdle means you must pass the exam in order to pass the subject. And in order to pass the subject, you need to get 50 in your subject, right? and pass the exam. But the exam pass mark could be different to 50. All right, so what we do, we look at all the exams, and we don't want to fail 90% of the subject, right? So do your exam the best you can, ignoring the hurdle, okay? Just the best you can. Why I say that? Because it happened that some students gave up in the middle of the exam, thinking, I will never get to 50, okay? So don't do that, because the actual pass mark could be lower, okay? And often it is lower than 50, just to cross enough of you for next semester, all right? And if you fail the exam pass mark, okay, it means that you are pretty low in comparison to the rest of the cohort, okay? So my personal belief is this. If you attend all the classes, if you honestly do your assignments, if you ask me any question that you don't understand, you are safe, totally safe. Okay, so from all the past years, I never knew in person a student who failed. It was always a surprise. A student would come to me, I failed, how come? Who are you? I don't know you. Hello. So it's those of you who are hiding at home, replaying my lectures, pausing wherever you want to pause, and essentially making your brain slow thinking. Normally these come sad at the end, okay? Okay, now my consultations, this is important. I have that underneath. So it says, after this lecture, just follow me to my office and ask me, grill me, anything, okay? I mean, I'm really happy to help, and I'm dedicating this hour and 15 minutes for you. Make use of it, seriously, make use of it. I love my consultations. I get to see the students one-on-one and see what they don't understand and what I should explain better in class to everyone. Okay, if you don't come, if you just rely on your friends or your self-learning, I don't get to realize what is difficult for you, all right? So definitely come to ask me and meet other people who come to my office, all right? Feel free. This is for you with best intentions. In addition to that, okay, so if you have any question whatsoever, come to my office. If you can't for some reason, or it's not Friday, you have these other options, the discussion board, tutors' consultations, or during the study group, the workshops that they are going to attend, you can ask them as well. Okay, so all of that is for you to use, and have no excuses for getting stuck with your assignments, okay? Because you will have 3 weeks to submit your assignments from when they are released. So do make use of the consultations. And additional reading is essentially a redundant slide. Why? Because you don't need, I rarely see a student coming to me, hey, I see this problem in this textbook, help me solve it. You can do that, okay? So if you are bookworms, by all means, open the chapter for three-dimensional motion of rigid bodies in any dynamics book and just practice, okay? I don't follow any books, and at uni myself, my personal learning style, I never used books, textbooks, okay? So I just wrote to you these titles because if I don't, students are nagging, give me a book, give me a book, give me a book. Okay, so. Okay, now this is my comment about the learning styles of the fails and the pass students. I think it's self-explanatory. These stand for your assignments. If you struggle with your assignments, you're in a good position, okay? If you struggle, if you think about them deeply, if you come to seek advice from me, from the tutors, if you do the hard work in your assignments, you're good, okay? I nearly guarantee, I mean, if I weren't recorded, I would guarantee that you pass, okay? you pause it, you can edit. Okay, if you take the shortcuts, if you take the easy way, if you ask your friend, hey, question 7, what did you do? You're risking yourself, all right? Okay, just saying. Now, before we go to the right-hand rule, swiftly, there is here some information related to assignments and practical, okay? When do you need to read that? Today, okay? In between the lectures. If you don't have anything to ask me after this class, read this, okay? Read this and don't say, I didn't know. And
there are plenty sheets down here if you don't have it.
yeah, if you don't have, we have like 100 more here, which suggests that many of you are absent, perhaps due to a clash or already, I don't know. You have the late submission penalty, which I will summarize as late is late, okay? Anything after 8 p.m. when the assignment is due is late. Even if it's a millisecond late, it's 10 marks off, okay? So if you see that you, for some reason, you cannot submit by 8 p.m., you might as well take the entire 24 hours following that and like, think it through instead of just submitting in a rushed way. But I suggest, okay, and there is no buffer, nothing, okay? It's due 8 p.m. Any millisecond after that, you're late, okay? And there is no mercy, as I state. The reason I state that, I want to be fair and equal to everyone, okay? So I don't want in private emailing, sparing some individual students, okay? So make sure your internet connection is okay at the submission date. If you are forgetful, like put all your organization skills in place to submit it on time if you don't want the penalty. Accidental submission, okay? No excuses, no submission. If you did everything but forgot to click the submit button, no excuses. And unfortunately, I need to say that very clearly, okay? Because all the possible scenarios I've encountered already, and every time I go, I need to put that. And so I did, okay? I was sitting for a whole day thinking, what students could have potentially that I need to say, no, not accepted, not accepted, okay? Special considerations, read that when you can apply, like if you're sick, what to do, all right? And for exam special considerations, read that 3 times before the exam, all right? Because I'm not responsible for anything that happens to you once you are at the exam venue, all right? I can't grant you any special considerations, things like that. Okay, let's quickly go, like 2 minutes, 3 minutes, to the right-hand rule. Okay, I might start from that, the afternoon lectures, okay? Come to the afternoon lectures, they are super important. Okay, now often when you work in 2D, you have the x-axis pointing to the right, the y-axis pointing upwards. We are going to make our mind so flexible this semester. Every axis can point everywhere in a 2D kind of drawing. So if we have something like that, right, we are sticking still with the right-hand rule. So all our coordinate systems are right coordinate systems, or with the right-hand rule convention that x cross y gives you z, okay? So how to find out where z is in this drawing? What do you say? So if you are doing like that, it's fine. So what do? I'm working with this kind of hand waving screw type of convention. Okay, not the I'm going to shoot you thing. You point your fingers to the X, then you sweep the area towards Y, okay? And as you are doing that, your thumb will be pointing to the Z, okay? So try that. In my exams, I see all the students doing that all the time, all right? That's fine. What's not fine is doing that, okay? I see that too, okay? So your right hand only, okay? That's why no wedding ring here. So on this, take your right hand, fingers, 4 fingers from the X to the Y, and your thumb is pointing into the wall, right? So your Z-axis is going into the wall. Okay, now this is if you see your X and Y. What if you see Y and Z? What do? You kind of do the same thing, but instead of going from X to Y, you go from Y to Z. Okay, so if you go from Y to Z, your X will be pointing out. Okay, so like that. Okay, from Y to Z. And how to find the direction of Y? Z to X, right. So just remember the order, this X, Y, Z, X, Y, Z, X, Y, Z cycle. If you want to find Y, you go from Z to X. Fingers, Z to X. All right? So I will let you go, and we continue afternoon. Thanks a lot, guys. Thank you. Thank you so much. Thanks.
I haven't been able to register the lectures this afternoon online.
Come anyway.
Check when they were.
When? Go here. You see this link?
Yep.
You can go to LMS, right? So
yeah.
this is in the subject information. Go here, and you will see the lecture.
Okay.
Yeah.
We have a tutor this one.
Yes.
Tutor letter today. After
I think one. Check here for all the times.
There's another lecture at
3:15. Yes. Class.
is a Friday one.
Is that in LMS, right?
Yeah, it's recorded.
Oh, thank you.
So like we have one tutor letter right now. We have to come to that exam next week or this week.
You have all your tutorials starting from this week.
Okay, we have it. And we
Yes,
have to bring a
we do.
laptop.
If you can, if you don't
Because I have
have,
a lecture right now and after that I have it to you.
if you don't have, just come without your laptop.
Okay, and
But do
regarding the
come.
stuff with the Friday change one, that we made changes for this one. Right? We
Yes.
made it on Thursday. We have a practical and lecture already at that time.
Another subject.
Yeah, we have control system practical, control system subject and practical for design and manufacturing. At that particular time, so
It's a problem of this university, all these classes. When I book something, I'm not aware of everything else, and it's I will record it. I mean, I will try to record it. I'll do my best, but what can I do? I can't change it. I can't change the time and
Okay.
place. Sorry about it.
No problem.
Okay, it's been booked like ages ago.
Oh,
Sorry.
okay, it's okay.
It's a tutorial question, even though it hasn't started.
Sorry, just a second. Are you?
Yeah, thank you.
Thanks. I'll come there.
That's
Thank
great.
In the last question, it asked us to film a video.
Yeah. Why don't you come with me to the office for that? So in case there is another lecture happening. those